Good morning. Thank you for coming. Well, this talk has a very misleading title. First, you should not expect me singing. This is not going to happen. And secondly, it features Scala in the title, but I feel that what I'm about to say could apply to pretty any new technology that is not yet mainstream. So in the next 45 minutes, I will be sharing with you some of my personal experience. From this experience, I will try to extract some tips and tricks. And to illustrate my points, I will make very poor pictorial metaphors, which are taken from a slightly famous TV show and may constitute spoilers. So before we begin, if this picture means nothing to you, or maybe this one, or even that one, but seriously, if you've never seen that, that means you've not been on the internet for the past 5 years. So, my name is Valentin. I'm a Scala developer in Paris. But before being a Scala developer, I was a mainstream developer. I developed in Java. And so I think it's a good starting point for our story to begin with what it is to be a mainstream developer. So here is our mainstream guy. He's very handsome. He has obviously hands-on experience. He knows all the yeah, he knows all the handy tricks of his craft. And this guy, he has a motto. Well, sorry, not that one. His motto is that a developer always pays his technical debt, which of course is rather inaccurate because a developer always pays others' technical debt. And maybe it's the starting point when you've faced a new technology. You begin to see all your mainstream code as technical debt and clumsy and cumbersome. But of course, using a mainstream technology doesn't have only drawbacks. First, there is a lot of jobs. So if your job is becoming boring, you can easily quit it and find another one. But of course, since there are a lot of jobs, chances are your job will become boring. And rather on the same idea, since the technology is mainstream and you master it, it can become comfortable. And so you don't have a big pressure to get better. But on the other side of this same coin, you can start to feel that you've seen everything. You know everything there is to know, and it can become boring. This sums up is in this little diagram, where on the top you have the expectation curve, which starts on the left with a technology trigger. Then there is the hype. Then people start making mistakes, and bad press begins, and then the expectation drops. And finally, we get better, and we reach a plateau of productivity. And being mainstream means you are somewhere on the right of this point. Which means also that a lot of experience has been collected through the years, and there is a lot of material online to learn and get better. There are blog posts and books and conference talk. And all in all, it means that it is really easy to bootstrap newcomers with a mainstream technology. And you have mentors in company and so on. But of course, this also means that there is nothing more to explore, or almost nothing more. And that's why we become bored with, say, Java or C# or PHP. And because of that boredom, you decide to explore a new and shiny new technology. So you pick up one, you begin to learn it, and now you want to use it in your day job, and so you search for a job in your shiny new technology. And of course, since it is not mainstream yet, there are not a lot of jobs. So what do? Well, first you can try to create your own job in your shiny new technology by convincing your manager to use it for the next project. But it's not always successful. A good starting point to try to find a new job in this little niche of new technology is to try to bind with the community of that technology. And the best place for that is your local user group. So if you're a new practitioner of an emerging technology, and there is no user group in your city about it, you might create one. You can also, of course, go to conferences or chat with people on Gitter or IRC and so on. And finally, you'll need to be patient because it's still emerging. So an opportunity may arrive, but somewhere in the future. In fact, I discovered Scala in 2012. And from the beginning, I wanted to work with Scala, but I had to wait until late 2013 to find my first job in Scala. But in the process of binding with people and trying to reach that new community, you might feel that feeling that this poor little guy never felt, which is the imposter syndrome. I'm part of the team that runs the Paris Scala user group, and we have a monthly meetup. And at each meetup, there are a whole bunch of people who come there every month, but they leave at the end of the last talk. And I feel that they miss the most important part of a meetup, which is binding with people. And they do so because they do not feel entitled to take part of the community, because they are newcomer or Scala is just their hobby language, and they feel they do not have the right to propose talks and just chat with people who are working with Scala on a daily basis. And this is wrong. So if you feel that way, I want to tell you that you should not. You should step up and bind with the community of your shiny new technology. But finally, you buckle up and you try to pack your things and go to the edge of the civilized world and try to join a little company that uses this shiny new technology. And chances are you will be the first developer in that new team or new company. And you take on a project and you make progress and it works. And after a while, a new developer comes. Or maybe is it a graduate student or even an intern. And without notice, without having wanted it, you find yourself being a leader of a shiny new technology team. And maybe this isn't comfortable because, after all, you're still a beginner. You're not an expert yet. And you keep hearing that little voice in the back of your head, reminding you on a daily basis that, well, you're not an expert yet. And this is probably another flavor of the imposter syndrome, but a good one this time, because it will push you to get better and to make progress. But of course, it also can be overwhelming, because now you're in a team. You are tasked to produce software, and you're not an expert. So there is that double pressure. You need to produce software, and you need to get better. And in fact, you have a big responsibility. You have a responsibility toward your team and your boss, because you need to produce software. But you also have a responsibility toward the community of that shiny new technology, because if you fail, yes, you will be blamed. The team will be blamed. But chances are the technology itself will be blamed, because it's new, because it was risky to use it in the first place. And so things can become a little overwhelming. And when you're under pressure, you will make mistakes. You also will make mistakes because you're in a completely different landscape from the mainstream technology you've used before. With a new and emerging technology, you are somewhere on the left of this point, which means that the biggest mistakes with that technology are still being made. They are not yet very documented. And also, there are not a lot of material to teach and to learn and to get better. And in fact, that was the point where I was when I started using Java in a little company. I joined a little startup in 2013, which whose mission was to build and deploy a website for pharmacies in France. Website that would allow to sell drugs online, which is a very regulated activity in France. And because of that regulation, we had to deploy our websites on very specialized hosting companies. And these companies were, in turn, extremely expensive. And so our challenge was to build as much as website as possible with as few as possible computing power. Before I joined the company, one of the co-founders has built a little proof of concept of the platform. And my task was to take this proof of concept and make it better and suitable for production. But of course, I kept hearing that little voice in the back of my head reminding me that I was not an expert yet. But at the same time, I felt a very schizophrenic feeling. That was that I knew nothing, but yet the few I knew was so much powerful that what I used when I was programming Java, that I was in a very mixed state of mind. And this can become very dangerous. It can lead to something I call over-cleverness, which is, of course, not a real word, but it's like hubris, but applied to programming. That is, abusing language features or libraries you've just learned and put them everywhere. So for example, if you know a little Scala, that can be using implicit parameters to pass dependencies and having implicit everywhere. Or maybe using actors to model everything, even if you don't need to have concurrency or resilience. And this is, in my sense, the biggest enemy for a noob in a shiny new technology. And of course, since you have to produce software, you are under pressure about time. Moreover, if you're in a startup which has not much money, you have to produce software very quick, which means you will have few time to learn and get better, and few time to teach to your coworkers and help them getting better with that technology. And this kind of pressure made me make big mistakes. So this is not meant to be read. Don't try to decipher that crappy code. We were using the Play framework, which is an MVC web framework. And this is an action in a controller. And at that time, I was very happy with that solution, because after all, it's only a single function call. yeah, it's quite big, but it's only about, say, 40 lines, so it's okay. But no, I know that this is utterly crappy code. There is a mixing of language features, and there is a play plugin used to do dependency injections. It's awful. And I knew it. So after a while, I tried to write things in a slightly better way, using the Scala Z library. If you don't know the Scala Z library, it's bits of Haskell ported to Scala. It's objectively better, but it has some drawbacks. For example, these mystic symbols there. Nobody knows what they do. But it was better. But what was very wrong in that code base was that I've mixed some of this style with the previous utter crap. And it ended up having a code base with a style which was completely scattered and not consistent. And a few months after trying this style, I had to part ways with that little company. And a few months later, I came across my ex-coworker at a conference. And I went to him to ask him how he was doing and if he made any progress. And I was only met by his angry face saying, "Go away. I don't want to speak with you. I don't want to have anything to do with you because it's been months I've been suffering and struggling with your crappy code." Wow, that hurt. I mean, that hurt really badly because I knew the code I've left behind was not so good. I even gave him my personal phone number, telling him, you can call me anytime you find something completely mystic in the code. I will help you. And in fact, we had a very strict code review process in that team, which meant that he had reviewed every single line of my crappy code. So what was the problem? I mean, was it not crappy before and crappy now? I don't know. But I realized that when you use a technology that you do not completely master, and that allows to have multiple solutions for the same problem, code review is not enough to ensure a code quality. Because since you're still learning, and since there are a lot of ways to do the same thing, your notion of good code will evolve with a long time. And so the good code for today can look crappy tomorrow. So I decided to get better. Seriously, this was really a traumatic experience to meet that guy. And I really thought he will be punching me. So I decided I needed to get better. And a good starting point, I found, to get better and focus on how to get better was when you do not have the time to it, was to get back to the basics and to ask yourself, how do I sell this technology to my manager? Certainly, you won't need to tell him, yeah, it has a very big abstractive power, or I can write elegant code, or I can do category theory. But the selling point from the manager point of view of functional programming is productivity. You will write less code, you will make less bugs, the code will be more testable, more debuggable, and so you should be able to do more with less manpower. That's the selling point, in my point of view, for functional programming. And starting from that, you can make up a strategy to get better. So I had a problem. I was still using the Play framework. So I was writing controllers and actions. And I wanted my actions to be very simple. Because after all, an an action in a controller in a well-designed MVC architecture, it does only three things. It reads a request, it validates it, then it calls a bunch of services, and finally it builds up a response. Very simple. And so these are three steps. And in Scala, you have a nice construct called for comprehensions that fits that step structure. So I wanted my actions to be single for comprehensions. But the problem was the compiler wouldn't let me do it because I have different types involved. And in a for comprehension, you can only put one type. So I had a problem. And the first thing to do when you have a problem is to think about it and write it down and scratch your head. So that's what I did. I tried to write down the types that were involved in my various steps. So in the Play framework, when you validate a JSON payload, you get back a JS result, which is more or less, it resembles either. It's either the type you want or a list of errors. Similarly, when you validate a form, you get back a form of X, which is not either-like type, but it has a for method to which you can pass two functions, one to manage the errors and one to manage the happy case. So it's more or less like a either. Of course, you will call services, and often, most often, services involve speaking to an external system, which is encoded in Scala with a future type to encode asynchrony. But of course, these service methods could return a result or nothing, which make a future of option of X, or maybe a future of either an error or the type you want. And in the end, you need to return a future of results, result being an HTTP response. So that was the steps of my problem. But I still had no solution because I knew nothing. So now I needed to search for the web, on the web. And that's where the problem begins, because in functional programming, and especially at that time, since functional programming uses mathematical concepts, and those mathematical concepts have name you cannot make up, you don't know really what to search for. For example, I've tried a million times searching how do I put different types in a for comprehension, and I find nothing. So I needed to learn a deeper functional programming, but I had no time for that. So I came up with a little strategy to learn just enough to know what to learn next. So first, I gathered some knowledge sources, which are basically Twitter accounts I follow. Those are prominent practitioners of functional programming, or bloggers, or conference speakers. And they will feed you with new concepts, new libraries, new mathematical names. And of course, you don't have the time to get deep in all that knowledge. So next, I tend to build a mapping between names and very vague notions of what these things are good for. So for example, I knew only that monads were for managing effects and had something to do with for comprehension in Scala. Or for example, that the shapeless library was good for generic programming and abstracting over types, and so on. So I knew very little but just enough to know where to search when I will have a new problem. And that's what I do. When I encounter a new problem in my day job, I reverse that mapping to find the name of the concepts or libraries that I should now learn. And that's how I try to learn about monad transformers. I don't know if you're familiar with that concept. It's not really important for the talk, but monad transformers that allow you, they allow you to mix and stack different monads into a single new monad. So for example, in my very home problem, the solution was to use either t of future of result and x. That will be my new monad. That will be the thing I would be able to put in my for comprehension. So now I had my solution. And during a weekend, I wrote a little DSL that would allow me to use a single for comprehension for my actions. So this is quite simple, even if it doesn't fit in the screen. Oh, sorry. Here I have the validation of a JSON payload, which returns me a quote, which is an object in my domain, or I will return a bad request if it doesn't validate. Then I call a service that returns me a future of option of user, which I call the user, or I return not found, and so on. And so with that little DSL, I was able to transform each of my types into this new either t future of result and x. And this gave me a really cool DSL, which is published. You can use it. It's, the link is there. But this is not the most important point in that process. The most important point was that the Monday after that weekend, I refactored everything to use it everywhere. And I feel this is the most important part when you search a solution for a problem you have at work. Because people, the developers, they tend to, especially newcomers, they tend to take inspiration from the existing code. And by taking inspiration, I mean copying, editing, and pasting, which is completely okay. As long as people try to understand what they are doing, copying and pasting is okay. But it makes very important to have a single style in the whole code base. Because if you have different sources of inspiration, the code will quickly decay and become completely inconsistent. So when you find a solution, and even if you find a partial and not completely acceptable solution, you should try to refactor everywhere to use it. It is really important. And finally, when you've done that and you're happy with your solution, the next step is profit. In fact, in that project, that little DSL, it made up able to write better code, cleaner code, faster, and it forced us to think about every possible error case, which was really, really cool because we had, in that way, we had a very self-debuggable API. Since we were using different HTTP status codes for each error case, when an error arises on the API, we were able to quickly and easily track where the problem arose. So that was the biggest profit of that little library. And personally, it had an important impact on my life. It was the first, and for the moment only, library I ever published. And it was also the subject of the very first talk I ever made. So after that point, I felt that I was not yet an expert, but I was in a better shape to lead teams. And I was ready to live with that imposter syndrome without having it overwhelming me. But don't get me wrong, that little voice, they never shut up. I mean, I've been doing Scala for nearly 4 years. And there are still so many things I don't know that I still feel like I know nothing. But it gets better. And I feel it's good to remain humble and remain aware of what you don't know. It pushes you to learn new things. But now, I am more confident in leading teams, even if there is no lead in my job title. I mean, you don't have to be explicitly the leader to be in leading position. And I try now to bootstrap newcomers and juniors the quicker I can. And to that purpose, improving on tooling is very important, especially in the Scala world, where our main tool is SBT, which is known to be a little cryptic. And if you experienced enough to master SBT, maybe a good thing to do is to use its extensibility to provide some helpers and little tools that will help newcomers and juniors to bootstrap projects really quickly. That's what we've done in the project where I work currently. We added some little functions that allow us to create modules in a single line with a whole bunch of preset libraries, dependencies, settings, and so on. So that the juniors in the team that do not need to learn SBT before they begin to work. Of course, they will learn at some point, but for now, they can skip it and being productive. These sets of little tools, they also include some project skeletons. That is, when you use the little helpers to create a project, then you have a new command in SBT to initialize your project with unit tests. And for example, for a microservice, you will have an health check on endpoints and so on. And so you lay up a project so that the junior, when tasked to create a new module, in 5 minutes stop, he can begin to write the real code. And he already has an example test and so on. And finally, but more importantly, pair programming is really, really helpful to help ramp up juniors. When a junior in the team has a problem, when I see him or her struggling on a specific problem, I always sit beside him and we try to find a solution to the problem together. And using that opportunity, I try to introduce new concepts and new ways of doing things. It's important to introduce concepts only when they are needed, because you connect this concept to a real usage right on the point. And finally, when your code base grows, enough, you will not be able to apply the refactor everywhere step I mentioned before. So you need a way to have a code review process that will accommodate to the changes in your style. And this, honestly, this is something I've not experienced yet in a team, but I feel that is a good starting point. When you use a technology where there are many ways to do the same thing, the team should agree to one local best practice. And the team should write it in a wiki or on a README in the Git project with rules, simple rules, named and agreed upon by the whole team. For example, in Scala, it will be the team chooses to represent enumerations with sealed trait and case object. There are various solutions for that very specific point in Scala, but you have to choose one. Then, upon code review, you ensure that the whole file that is touched by a commit applies the rules that are agreed upon. And the important part is the whole file, because you will need to be able to amend and make and evolve the rules, the style guides of the team. So maybe the file was correct before the next evolution of the style guide, but now the style have evolved, and you have to make sure the file will evolve with the style guide. And then you can repeat that process as long as the team gets better and masters new ways to do things. And you keep the code base the most consistent possible. So that's it. That was my little tips and tricks and experience about being a leader in a shiny new technology. If you want to keep in touch, these are my Twitter handle and GitHub accounts. And I guess we have plenty of time for questions. Thank you.
Thank you.